Okay, we're going to be talking about simplifying radicals. So let's just go over some symbols first. That's a square root symbol. I'm going to put a letter A underneath there, which could represent any number. And this symbol right here is called your radical symbol. It's really important. Like I said in class, we need to know our vocabulary terms. And the A is called your radicand. Okay, make sure, again, you're writing this down. All right, we need to have some rules. Always there's rules when you're simplifying radicals. So copy this down too. An expression with radicals are in simplest form if the following are true. So when you're trying to simplify radicals, you're going to go through these checks and balances, we call them, to make sure it's in simplest form. So one rule is no perfect squares, or perfect square factors, I'm sorry. Other than 1, because 1 is a perfect square, are in the radicand. Example, let's look at the square root of 8. It's not a perfect square, but we're going to actually simplify that, okay? If you look underneath that radical, to simplify this, you want to pull out a perfect square. So if I say 4 times 2 equals that 8, right? Now we can simplify that to the square root of 4 times the square root of 2. And the square root of 4 is 2. And we can't pull anything out of this, so the answer is actually 2 times the square root of 2. So the rule is, it says there are no other than 1 in the radicand. So let's look at this radicand. We can't simplify that anymore. The next rule, let's make some more room here. No fractions are in the radicand. So for example, if you were given the problem, notice the square root symbol is over the numerator and the denominator. So we actually can separate this, and we could say the square root of 5 over the square root of 16. The square root of 5 cannot be simplified any further because there are no perfect squares in there other than 1. So that stays like that. And the square root of 16 is 4. And according to the rule, it says there's no fractions in the radicand. All right? And the last one would be no radicals appear in the denominator, which is the bottom number of the fraction of a fraction. And your example on that one would be, say we have 1 over the square root of 4. Okay? We can simplify that square root of 4. So 1 over square root of 4 is 2, and then it's in simplest form. Okay, so there are 2 ways to simplify an expression. 2 ways to simplify an expression. So what I want you to do is separate your paper. On the left-hand side is going to be, the first way is use product property. By removing perfect squares. from radicand. And let me show you how that works. Example, square root of 50. We know that's not a perfect square. So we have to get it to its simplest form based on those guidelines that we had before. So would you agree? What I want to do is, would you agree first of all, 25 times 2 does equal 50. And what I'm trying to do is I'm trying to look at that 50 and say, what perfect square is within that number? What can I take of a perfect square and multiply it by another number, and it's going to equal 50. Okay, so 25. So now I'm going to break that down. So the square root of 25 times the square root of 2. If I took those two radicals and multiplied them together, I would get the square root of 50. Now the square root of 25, what is the square root of 25? It's 5, and times the square root of 2. If I want to check this, I can say 5 squared is 25. 25 times 2 gives me the 50. Okay, so that's how you can go back and check your answer. And I'll show you in the calculator too once everyone gets their calculator. The other way is called upside down division. You are allowed to pick either method you want, or you can use both methods depending on what number you get. So I'm going to use the same number again. So square root of 50. So now I'm going to take this 50 and I'm going to do upside down division. If you haven't seen that, it takes a little bit, but then once you get started, you'll understand it. Okay, so with the upside down division, you want to take the smallest prime number. Okay, smallest prime number. So let's divide it by 2. 50 divided by 2 is 25. I would keep on dividing by 2 until I can't anymore, which means I can't anymore. So now my next number would be 3 for a prime number, and I can't divide that evenly by 3. So then my next prime number would be 5. So 25 divided by 5 is 5. If you take all of these numbers and multiply them together, they should equal what's underneath that radical symbol. So 2 times 5 is 10, times 5 is 50. Okay? Now, to simplify this in this method, I need 2 of the same factors to pull one out. So, meaning pull it outside the radical symbol. So I would pull out a 5 and the 2 still underneath. What basically it is let me show you underneath here. This is a 2 times 5 times 5. And I would find my 2 pairs. You need 2 to pull out 1. Comes outside in the front. And notice I get the same answer on the other side. Okay, so now let's try another number. We'll use both methods because I want you to make sure you have an option. So the square root of 44. So with this method, I want to find a perfect square multiplied by another number to get 44, because I know the 44 is not a perfect square. So if I take 4 times 11, I get 44. Then I can say the square root of 4 times the square root of 11. Square root of 4 is 2, and it's simplified. Let's do the upside down division. Remember, you start with your smallest prime number. So 2 times 22, divide by 2, and it gives me 11. I find my pair because it's a square. I need 2 to bring out 1 outside, and I have the same answer. Square root of 90. Let's practice some more. So the square root of 90 is the square root of 9 times 10. Square root of 9 is 3 times the square root of 10. 3 times 3 is 9 times 10 is 90. Let's do the upside down division. So I'm going to divide by 2. Gives me 45. Can't divide by 2 anymore, so I'm going to go to 3. I get 15. I'm going to keep on using that 3 until I can't use it anymore. If I multiply all of these numbers together, I get 90. Now I'm going to look for my pairs. I have a pair of 3s, so 1 comes out. Well, 2 and the 5 are still left underneath, so I have to multiply those two together. That gives me 10. So 3 times 3 is 9. I'm squaring that. Times 10 gives me 90. Okay, we're going to do two numbers and we'll be done. Let's do the square root of 27. I need a perfect square. 9 times 3 gives me 27. Square root of 9 times the square root of 3. The square root of 9 is 3 times the square root of 3. 3 times 3 is 9 times 3 is 27. I know that's my answer. Okay. And let's do the upside down division. So upside down, I'm going to divide that 27 by 3. 3, 3. I need 2 or a pair to pull out 1. Notice it's the same. One more. Actually, I think this is what I'm going to do. This is going to be your homework. I want you to find the square root of 48 in simplest form. And then use the upside down division too, just to practice and see which one you like the best. Okay? All right, go ahead and do your assessment as well.